And welcome to SanfordFlipMath. This is PreCalculus. We are working from the Demana Foley Kennedy book, Graphical Numerical Algebraic for PreCalculus, 4th or 5th edition, depending on which copy you have. And we are going to work from section 2.8, which is specifically about solving inequalities in one variable at a time, that is. And we're going to kind of go back to something oversimplified, talk about it for a minute, and then we're going to extend it to stuff that's more interesting. And we're going to focus on a very specific process in just a minute. I just want to remind you what we're talking about. So if I have something like 2x plus 5 is greater than or equal to 0, just a reminder that typically how you solve this is just like you would in an equation. It's just there are some issues as you go along. So minus 5 on both sides, so 2x is greater than or equal to negative 5. Divide both sides by 2. X is greater than negative 5 over 2, or you might prefer negative 2.5. Just a reminder that the idea here is that if I do a little number line, okay, so at negative 2.5, halfway between negative 2 and negative 3, that's where the boundary is. The boundary is basically where things switch from things that work to things that don't work. Okay, so where we, the points where the inequality switches, where the inequality changes from solutions to not solutions. Okay, that's very deep, isn't it? Okay. So in this case, at negative 2.5 or at negative 5 over 2, that's where we switch from things that are solutions to aren't solutions. And then the question becomes, okay, which ones are solutions? Well, in this case, it's pretty obvious. It's the values that are greater than or equal to that value. So things greater than that are like negative 2, negative 1, 0, 1. Those are all bigger than negative 2.5, so we would shade to the right. Okay. Now, and then the other issue is, yes, you fill in that point because of the or equal to. In other words, the boundary itself is a value included. Okay. Well, what happens when we're talking about something a little more interesting, like for instance, x squared minus x minus 6 less than 0? Well, if it was equal to 0, then I would actually factor this, and I would get x equals 3, x equals negative 2. Well, the problem is that I can't just take this down that little list and just apply it here and here, and that's a common mistake. You can't do that because we don't know how these two factors interact with each other. This says less than 0, which is negative. So this whole thing, this x minus 3 could have been positive or negative. This x plus 2 could have been positive or negative. And if they were both positive or both negative, then that less than 0 wouldn't happen. If one of them was negative and the other one wasn't, then it would. So what we need is a way to keep track of all this. And so what we're going to do is what's called a sign chart. Okay? You could just do test points on a number line and shade where it works, and that's typically what I do in an Algebra 2 class, but I'm looking for more information than that. Okay? So the question at this point is, now what? This is a more complicated equation. Okay? So, or inequality, I should say. Okay, so we're gonna start over on this. X squared minus x minus 6 less than 0. And what we're actually going to do is, again, we're going to find the boundaries. Well, let's tighten this up a little bit. Boundaries happen where the inequality is equal, or any kind of a domain issue. So in other words, if it makes it undefined, or if I end up doing the square root of a negative, so wherever that starts, etc. Okay, so any kind of a domain issue, or any place where it's equal. Okay, so in order to find the boundaries, okay, I'm not changing the problem, but in order to find the boundaries, I'm going to make it equal. So I'm going to repeat the steps I just did. Okay, and this is where the boundaries happen. So again, I'm going to either do quadratic formula or I'm going to factor. Okay, and again, this is not anything new. I'm not going to spend a lot of time on this. Those are the boundaries. And then what I'm going to do is build a sign chart. Now, a sign chart is kind of like a little mini number line, but it has more information. So I'm going to put x values and y values, and they need to be numbered from left to right, from low to high. And the x values I'm going to be concerned with are the x values -2 and 3. And then what I'm going to do is list what those y values are for those values, for those points. Okay? Well, I know that if I put 3 into this equation, I know I'm going to get equals 0. How do I know that? Because I just solved this thing. So -2 makes this 0, and 3 makes this 0, because I just solved that. And then what I'm going to do is I'm going to look at the x values that are to the left of -2. I'm going to look at the x values between -2 and 3, and I'm going to look at the x values to the right of 3. You might choose to write that like this, and you are welcome to do this. We are not including -2 because that has its own little slot on this table. You could write -2 to 3. You could write from 3 to infinity. Okay, so what we're going to do is do a test point. Okay, so a test point is just a point in that region of those x values. And what we're going to do is get a y value for those. So a point for those x values. And really all I care about is whether the y values are positive or negative. Because if you recall, we have this set up so that this is about 0. And in words, what that means is negative. So all I care about in here is whether it's positive or negative. Okay, so that's all I'm going to do is look for whether it's positive or negative. So let's pick an x value to the left of -2. You can pick any x value in the universe that is less than -2. And what I'm going to do underneath this table is a little mini version of the equation. Well, so what this says is x minus 3, x plus 2. Okay, so again, this comes from x. I don't usually write this part. So that's that one, and that's the other one. Okay, so sorry about that. Okay. So band practice was canceled, just so you know. Okay, so I'm going to put in a value to the left of -2. For example, x equals -5. Any value to the left of -2. So if I do -5 minus 3, that's going to be negative, I don't really care, -8. If I do -5 plus 2, that's going to be negative, again, I don't really care, -3. And the idea here is a negative times a negative, so I'm multiplying these, a negative times a negative is positive. Okay. I'm going to do the same thing in between -2 and 3. So I'm going to pick a value. Okay, so, and I just want to pick an easy value to work with, like for instance, x equals 0. Well, 0 minus 3 is -3. 0 plus 2 is positive. And a negative times a positive is negative. I'm going to pick a value to the right of 3. For instance, x equals 5 if you want. Could be 100 if you want. I don't care. And again, I'm going back to the original equation in factored form, and I'm saying 5 minus 3, positive. 5 plus 2, positive. Positive times a positive is positive. What we've just done, this sign chart is a bookkeeping tool to help us in deciding how to answer this question. Okay? So what I just found was where this function is positive and negative. And then based on that, I want to know where it is negative, well, it's negative here, so between 2 and 3. That's my solution. Or if you want to write it between 2 and 3, that's my solution. Okay, it just said less than 0. It did not say less than or equal to, just less than. So that's the answer. Okay, let's do another example. The process here is the same. We are going to first find the boundaries. Okay, and as I said before, the boundaries are come from where, instead of a greater than or equal to, where it's equal, or any time we have a domain issue. Now, please note that this particular equation is has a fraction, is a rational. So that means that we have a problem with the domain in where the denominator equals 0. Okay, so boundaries, again, for this one, it's going to be x plus 4 over x minus 1, where it's equal to 0. Well, I can solve this. This is a rational equation, and so I can multiply both sides by the least common denominator, which is just x minus 1. Now this is exciting stuff right here, because now it's x plus 4 equals, you guessed it, 0. So x equals negative 4. Now a quick little aside here. If I have a fraction equal to 0, notice that a fraction is equal to 0 when the numerator equals 0. Okay, well, x plus 4 equals 0 when x is negative 4. Okay, so that's kind of a little note to self. Okay, the other issue that comes along with this then, as I said, is any place where the denominator equals 0, we have a problem. So we have a domain issue when x minus 1 equals 0. We can't have that, so that's when x equals 1. Okay, so these are going to be my two boundaries. And so what I'm going to do is set up a sign chart. And I'm going to use negative 4 and 1. Now, worth noting that the negative 4 and the 1, I need to have space on both sides of each. And those are x values. Okay? And again, the negative 4 has to be on the left because they need to be left to right, small to big. Okay, just like on a number line. Okay, and what this is, what the sign chart is just an organizational tool that lets us keep track of all of our information. Okay? Now, x values to the left of negative 4 are the ones that are less than negative 4. X values in between negative 4 and 1, or x values greater than 1. Okay? And again, I'm fine if you want to use interval notation for this. Just please don't mix and match. Okay? Now, we need to also write down what were the values for, negative 4 itself made this equation equal to 0. 1 didn't make it equal to 0. 1 made the denominator equal 0, which makes this whole thing undefined. Okay, so I'm going to make a note here for 1 that it makes it undefined. Okay, so now what we're going to do is test points. So I'm going to pick a value to the left of negative 4, and I'm going to put it into x minus 4 over x minus 1. Now, so this is like my little mini version of the equation. I'm just going to write these underneath here, and all I'm doing is keeping track of signs, positive or negative. That's all this is for. Okay, so I pick a value like something to the left of negative 4, like maybe negative 10. Well, if I go over here, negative 10 plus 4 is negative, I don't care. Negative 10 minus 1, also negative, and a negative divided by a negative is positive. If I pick a value between negative 4 and 1, like for instance, x equals 0, I like that one just because it's easy to work with. Well, 0 plus 4 is positive. 0 minus 1 is negative. A positive divided by a negative is negative. And then last but not least, I pick something to the right of 1, like 7. And again, I'm just pulling any number out of the air that needs to be greater than 1. Okay, and so 7 plus 4 is 11, that's positive. And 7 minus 1, 6, that's positive. Positive divided by a positive is positive. Now, I haven't answered the question yet. Okay, this is a sign chart. This is an organized set of information that lets me now answer the question. Okay, so what I was supposed to do was solve for any x values that make this thing greater than or equal to 0. Okay, so now the question is, what does greater than or equal to 0 look like? Well, greater than 0 is positive, and equal to 0 would be that. Okay, so now I need to write that solution. Okay, so I'm going to write, well, that's true. This piece is any x's less than or equal to -4. This piece is any x's greater than 1. Well, x can't be both less than or equal to -4 and also greater than 1, so I have to write the word or in between. And that's it. Now again, if you'd prefer, you may certainly write it like this. I kind of like this. I think I like it actually better, but that doesn't mean you do, and I'm okay with that, just as long as you can read it, you know, on final exams and things like that. Who knows what kind of notation is going to be going on there. Okay? All right, so this is the solution or the solutions, and there we go. Okay, I'd like to do one more example. Okay, and let's do, I want to go ahead and do a factored form. And what we're going to do is write down A, where it's positive, B, where it's negative, and C, where is it equal to 0. I probably should have done that first, but all right, so whatever, we'll do that first, even though I should have written it first. Okay. All right, so quick little note to self. Boundaries are going to happen when this thing is equal to 0, because positive happens starting at equal 0, you know, just above 0, and negative starts at just below 0, and it starts where everything changes then is where things are equal to 0. Okay, so what we're going to do then, the boundaries then happen where x is going to equal 3, x would equal -1, and what about boundaries for that? I mean, for what x values are x squared plus 4 equal to 0? Well, that would have to be x squared equals -4, so x equals plus or minus 2i. Well, how do you do that on a graph or on a number line? You don't. Okay, so for these problems, we're not going to worry about imaginaries, because, I mean, how are you going to be greater than 2i or less than 2i or something like that? So we don't. All right, so let's do a sign chart. Really, we just have two boundaries. So we're doing x and y. The boundaries are -1. Now, don't think that every single time in the universe it's always going to be two boundaries. That's not the case. -1 does make this whole thing equal to 0. Okay, because it would be 0 times who cares, and that would just be 0. 3 also makes this whole thing 0. Okay, so we're going to test values to the left of -1. We're going to test values between -1 and 3. We're going to test values to the right of 3. Okay, all right, so worth noting that we have 3 factors here, and there's a squared one. Now, there are some options on how you might want to list this. Okay, now please understand that these are not little x's. This is not parentheses x and another x. These are parentheses. These are 3 sets of parentheses. Okay, so what we're going to do then is put in some points. So like a point to the left of -1 might be x equals -2. Well, -2 squared is going to be positive 4, plus 4 is, it's going to be positive. Now, can I just take a second here? I'll come back to the x equals -2. Isn't this factor always going to be positive? I mean, square a number and add 4 to it. So I'm going to kind of cheat and just fill those in right now. Okay. Also worth noting, this factor, once I get done squaring it, now it's not positive, the inside's not positive necessarily, but once I get done squaring it, won't it always be positive also? So I'm not saying a positive number squared. I'm saying after it gets squared, won't it already be positive? So really, the only thing I have to check is really this x plus 1 factor. Okay, so if I take this x equals -2, put it in here, -2 plus 1 is negative. Pick a value in between -1 and 3, and I'm really partial to 0, and honestly, the only reason is it's super easy. So 0 plus 1 is going to be 1, that's positive. And then this last factor, pick something to the right of 3, so I don't know, maybe 1700. Okay, honestly, it doesn't matter what number you pick. 1700 plus 1 is going to be positive. Okay, I know some of you are freaking out right now. X equals 4 would be fine. 4 plus 1, again, still positive. If the goal is to find out whether it's positive or negative, I can pick any number I want just as long as it's in that region. Okay? All right, so coming back here. Positive times a positive times a negative. Positive times a positive times a positive. Again, positive, 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 all positive. Okay, so let's come back and answer our questions then. Okay, so I need to make some room. Okay, so where is it equal to 0? Those were the boundaries I found originally. So that's x equals -1 or x equals 3. Okay, so that's the part that should have been part A. And then positive, well, it's positive. Let's do a little highlighting so we can see what we're talking about. Positive here and positive here. Okay, so that means, okay, so I'm going to do that in a color-coordinated fashion. Isn't that clever? Okay, so it's positive from -1 to 3 or from 3 to infinity. Okay, and then negative, okay, last little chunk. Let's do that one. Okay, so negative, that's the only spot where it's negative. Okay, and that will be to the left of -1, so from -infinity to -1. Now, again, I know some of you are saying, come on, Mr. Sanford, you know I hate that notation. Okay, well, just a reminder that I am perfectly fine if you want to write this a little differently. Like, for instance, if you want to write this part -1 less than x less than 3, x greater than 3. That's fine. It's just, I think it's easier to use the other notation, but again, it's up to you. For the x, if you want to say x less than -1 for that, that's fine also. Okay. And one last little bit of color coordinating just for the zeros, just so we're nice and complete. And there they are. Okay. All right. Well, thank you so much for watching, and we will see you in class.